I got the engine all kind of prepped and cleaned up. I'm going to fit the frame around the engine. This is your basic, standard FZR 400 frame, a Levitt twin beam frame. It's very simple, made out of press sheets, and I've had welds or engine mounts from the TZR850 welded into place on it, and I've had to kind of clear out areas inside the frame to go around the clutch area because yeah, anyway, so let's just fit that sort of into place. And that's how it fits. On the original FZR600 one that Lenhart and Wagner did, they actually more aggressively cut out this area around the clutch. Really, like, reduced it very much. Just, I guess, so you could actually, take out the clutch cover and everything like that and service the bike. But I wanted to leave as much metal as possible, so I removed the inside and boxed in that area around the clutch to kind of bring back as much strength as possible, because this is an aluminum frame versus the steel frame, and I just wanted to add as much rigidity as possible. And the engine here is a structural element with the frame, so I think it's going to be just fine to to run it as is. I will be keeping an eye out for like any stress cracks or anything like that, but I think as is it should be just fine. It's dual counterbalanced, so it's not absolutely smooth, but it's a pretty smooth running engine, and one that I test rode.
Trillions of investing dollars. But considering the risk and the long time frame, you could also imagine that not many people are willing to invest. So what's the reality? The best estimates show that U.S. venture capital firms have about 550...
Okay, and we're back for another thing. So, how about some basic data? One of the reasons why I'm doing this, and also to explain just the dimensional differences that I'm dealing with between the original Yamaha TDM850, which is where this engine came from, and the FZR400, which is what this chassis is that I'm putting it into. So the TDM850, it was sort of like, it looked like a dual purpose street bike, very upright, you know, a little mini fairing. I'll show you some photos of that. So the FZR400 is kind of constraining in a lot of ways. It is 4 inches, according to the factory manuals, it is 4 inches shorter overall in length, front to back. It's 3.5 inches narrower. It's 5 inches lower overall. And its wheelbase between axle to axle is 3 inches shorter. So it's a considerably smaller package to put this engine and drivetrain into. According to the scales of the factory manuals, the TDM850 is 93 pounds heavier than the FZR400. However, part of that weight is in the engine. The engine itself, compared to the FZR400 engine, is 34 pounds heavier. So that is kind of an offset. So overall, kind of what I'm shooting for is this kind of power in something that is smaller and about 60 pounds lighter than the motorcycle it came out of overall. Okay, so those are just kind of the basic things. I'm not going to go over to like every little thing that I've changed on the chassis. Right now, in this episode, we're going to talk about the lubrication system. In the original TDM 850, because it had so much more space, they mounted the dry sump tank, or the oil tank, behind the engine, kind of in between the rear shock and the engine. There's no space here for that to live. So I had to find space in a chassis that was narrower, shorter, you know, more compact overall. So what I did, I looked around and I was like, okay, well, on the far side of the engine here is the chain drive that drives the camshafts from the crankshaft. And over on this side, there was a little bit of space. So what I did was I mounted these down tubes, these cradles that are part of the original FZR400 chassis, and I covered everything in aluminum foil. And then I spray foamed everything kind of around here. And what I came up with after that was this kind of shape that essentially fit right up against the engine, kind of around that, allowed the cradling members to kind of fit up tight against it, and that was the volume that I ended up with. So yeah, I covered it with a little bit of Bondo and everything like that, just to make it a little more workable and durable while I tried to figure out how I was going to create this. And I originally tried to make it out of pieces of metal, and I might actually go back to that if this idea that I eventually arrived at doesn't work, but I'm hoping that it will, is I created this dry sump tank out of fiberglass and Kevlar. And what I did was I shaped some of that, you know, those sheets of blue insulation foam into this rough shape, and made it like about an eighth of an inch smaller overall to account for the thickness of this stuff. And I laid it all up and made like, you know, little steel plates inside sandwiched in there to hold on the mounting points where bolt to the cradle. And this is like the original filler out of the original tank. And so that mounts up there, and you know, the fairing panels and everything clear around it. There's space in between it and the engine. There's an air gap, and I'm probably gonna just put some like rubber padding and stuff like that around where it bolts in. I don't know if this is gonna work. I don't know. What I did in pursuit of trying to make this as functional as possible is just yesterday, I after preparing it, kind of roughing up the inside with some abrasive stones and stuff like that, and cleaning all that out, I coated it in Gliptol enamel, which is an extremely tough, oil-resistant enamel, which I guess some engine builders will put that inside. They'll coat like the inside of their engines to increase the oil flow back down to the pan, so that I don't know, I guess oil flows easier inside the engine. So that said, I'm not exactly sure how this is going to cope with, you know, 180 degree oil temperatures. This just might not work. We'll see. Yeah. So one of the things I was tempted to do in addition to this to increase its overall durability was to kind of prep it and, you know, block everything off and coat it in Line-X, because apparently in Line-X, I don't know if you've seen some of the videos, but it's an incredibly durable coating that creates these molecular bonds, which just, you know, will make something almost, you know, impervious. And, you know, if I ever did, you know, go down on this motorcycle, I mean, pretty much it's completely protected. You know, the engine and the frame and the metal steel cradle should protect it overall. But if something like impacts it, you know, which is also part of the reason why I use Kevlar in the layout process, in alternating the layers with the S-glass, is to make it as tough as possible, that, you know, that impacts wouldn't necessarily affect it. But yeah, I haven't seen this done anywhere else, so maybe this is just a shitty idea, but I'm just gonna give it a shot. Anyway, it's really light, and it bolts right up. And one of the reasons why, you know, originally this engine did not use any down tubes. It's a stress member engine, and it was mounted here and back here, and it just kind of hung in its steel chassis. However, I'm just, you know, deciding to increase, you know, the durability of everything by retaining these cradles, and there's like a big, heavy, really massively cast mount, which I guess this was part of, like, you know, when it went down the assembly line, it was kind of mounted on possibly a little stand like that, and, you know, the robots or the humans built it or whatever. So I'm utilizing this lower engine mount, which may increase the vibrations which are transmitted to the chassis. I don't know, but that's kind of what I'm thinking that might be, a result of. But that is, something I can live with. Regardless, I do like to over-engineer everything when I build it, and also, this has a provision for the side stand, and yeah, so I don't know. I think it should work just fine, but we will see. Now, moving on to the subframe of the engine, I kind of bolted up this little portion of the subframe that I had to modify. One of the things I did not want to have on this bike was the original seat. I mean, it was functional and everything, that was fine. I could have used it, but the seat was just really narrow and it wasn't comfortable for long distances. And so I initially, built it, kind of made I wanted to use the original TZR850 seat, and that was pretty big. And, it stuck way out, and I'll show you photos of that. And so I then kind of redid it, and this is, kind of like how it was in the second iteration. Still, visually, it looked too low in relation to everything else. So I chopped it up, and I'm going to remake it for the third time. And I'm going to actually, raise it up so that this top rail is flush with everything. And yeah, I will, I guess, maybe film some of that so you can see that. We shall see if this works. Yeah, so that's kind of where I am with this. I'm putting everything back together. I've been painting stuff that I didn't paint initially the first time, and moving out to California, I didn't realize how incredibly humid it is out here. Coming from Colorado, and I should have known that, but that's okay. So, yeah, that's kind of where we've landed at this point. And we're just going to keep trucking away at this. Anyway, that's it. Thank you for watching this little bit, and I will bring you some new updates. Bye.